Now, this is a topic I was very passionate about. And it happened in the past that I was passionate about some topics. And then I shared it with people and realized actually not too many people share the same passion. So if it's okay with you, I'm gonna run by you some statements. And if you agree with this statement, just raise your hand or give me any other visual or audio cue. So the first statement is that every developer loves to code. So all of you who agree with this, just raise your hand. Okay, nice. That's pretty much everyone. Now let's refine this statement a bit. So let's say every developer likes to copy-paste code, right? I mean, why would you spend your mental energy trying to figure out some solution where you can just copy-paste it from Stack Overflow or maybe just your old project, right? Now let's refine this even more. Every developer loves to copy-paste boilerplate code, right? No hands? I guess we are on the same page then. So boilerplate can be quite annoying. Now, if you Google for boilerplate, you might find on Google a picture like this. So there's some guerrilla going on. And among these warriors, you can see one specifically proud-standing fella by the name of Boilerplate. And here you can see him again. In case you haven't realized, the Boilerplate is the guy with the helmet. Now, if you consult Wikipedia and type boilerplate code, you get something like this. Boilerplate is section of code that have to be included in many places with little or no alteration. And this is where the whole copy-pasting comes into hand. Now, recently I saw an article that claims that 90% of good code is boilerplate. This sounds slightly controversial, right? How can code be good and at the same time boilerplate? It kind of doesn't make sense, right? But if you think about it, what makes a good code good? That means you're probably sharing the common architecture within your application. You're probably using the same style. You're using the same constructs for the components, for your services, for your models. And this inevitably means that you are doing a lot of stuff over and over again in your application, which is actually boilerplate, right? Copy-pasting the same things. So even if you don't agree with this number, I definitely don't agree with it. I think it's more fitting to maybe Java backend than front-end development. It's still a big number, and it's still something that pressures us on a daily basis. So before I move on to the actual topic of the talk, let me briefly introduce myself for those of you that don't know me. My name is Miroslav Janosch, or Miro shorter. I'm working at 5G Systems, building some gaming solutions of the future. I'm also one of the organizers of this meetup, as you can see with the t-shirt. I'm also co-organizer of Vienna.js meetup together with David here. And I'm also one of the co-founders of Angular Austria Association. If you want to say hi or just follow my tweets, you can find me on most of the social networks using this handle Miroslav. And it's exactly at 5G Systems where we have a lot of web applications. And some of these web applications are big enterprise applications. And some of these big enterprise applications share the same technology and same framework. And this, of course, means that a lot of the code gets duplicated between these solutions. So what happens often is we come up with some cool thing how to do or how to solve certain challenge, and then we simply copy the same approach to all other projects sharing the same technology. And also, we have a lot of features and a lot of modules in the project. And this also means that a lot of these concepts is copy-pasting from one place to another. This can be quite painful. Now, in order to handle our logic in the application a bit nicer, we, of course, as many other companies, introduce state management. And once we introduced state management, we realized that boilerplate of yesterday was child plates today. And state management brings the boilerplate to a completely different level. But state management is not that bad. It, of course, gave us chance to reason more easily about our application state, to debug more easily, to know exactly at every point what our application does, because every state or every view of the application is a result of the initial state and some steps that led to the current state. Now, as some of you might not know how the state managements work, I'm going to do just a quick 101 of what state managements look like. So in a nutshell, you have a store which has a state. State is nothing but an object representing some properties of your application. For example, it can say whether the menu is open or not. It can say what is the logged in user. It can hold information about some products that you want to show. So just imagine what makes your application dynamic, what are the things that change, and this is usually the stuff that you keep in the state. Now, state is then fed to the view. We can feed it directly, or we can use selectors, as Michal mentioned, or with some other libraries. It might have different name, like getters, but generally it means taking parts of the state and reacting in a view upon these state parts. Now, we need to be able somehow to change the state to lead it to a different state. So for this, we use concept called actions. An action is nothing else but a vessel that carries the information to the state. So what we usually do is we have this pipeline that carries all the actions to the state, and we simply create a new action. Each action has a type and can have some payload. For example, if we want to load the products, we can say that my action type is load products, and maybe my payload is some specific filter I want to apply. So I don't want to fetch all the products, I want to fetch just the products that have been added yesterday or that have serial code that matches some pattern. Now these actions then trigger something called reducers or mutations in some other libraries. And reducer is nothing but a function that takes two arguments, current state and an action, and produces a new state. So it simply calculates the new state based on information. And then reducer, as a result, sends this state back to the store. And you have the full cycle. You know, store showing view, view triggering the action, action carrying the information to the reducer, reducer calculating a new state, and sending it back to the store. Now this whole flow is synchronous. So what happens if we need to do something asynchronous, such as fetching information from our backend APIs? For this, we use something called effects, or in some other libraries, you can call it sagas or thunks or even async actions. And what they do is they also, in similar way like reducers, react to the action, and then they can do some asynchronous activities such as calling our backend APIs, getting the response, and feeding it to another action. And this action would then fall into the existing pipeline and might trigger reducer or might trigger a next effect. Now this is how the actions normally look like in the most popular library called NGRX. You usually have a class that has a name, for example, load product. It implements action. It has a read-only type, which is a string, and then it might have a constructor with a public payload. Now, since these strings have to be used all over the application, the reducer distinguishes between actions based on a type. Also, effect distinguishes between actions based on a type. So this is some piece of information we carry along the application. So it's advisable not to type it over and over because, of course, syntax errors are quite possible. Instead, there are two common approaches. We either keep it in a constant or in a enum like you see on the screen. So this is how our typical action looks like. Now, we might have a lot of actions. on the screen you can see three different actions. One is load product, one is product loaded, and the third one is product load failed. Now, it might not be clear initially by looking at this screen that there's a lot of boilerplate, but let's highlight the things that are different between these three actions. So I highlighted the stuff that's same. So as you can see, the only thing that's different between these actions is the name, the type, the type that represents the string, and the type of payload if you have any. And this is, of course, causing a lot of boilerplate. The team that's behind NGRX realized this, and they came up with construct called create action, and then create reducer and create effect to simplify the code. But at the same time, while this was being developed, us at 5G worked on our own solution using generics. And this is what I'm going to be talking about, how we solve this issue. Now, generics is perhaps not that popular in front-end development because it came with TypeScript. It doesn't exist in JavaScript. But it's quite popular for the backend languages such as Java and C#. Generics, in general, help you to create reusable constructs that can replace parts of your logic by simply having undefined or loosely defined types. So what it means in general, it means that you can create a construct that can do the same logic for different types. So for example, let's say we want to create a function that compares different items based on their serial code. Now this could be some laptops, this could be some clothing items, it could be even some abstract stuff. The only thing that needs to be common between these to use the same functionality is the existing of the serial code. So you can simply create generic type and say that the only thing this type has to satisfy is to have a serial code, and everything else is optional. Now, let's see how we used generics to simplify the actions. So here you see how the action looked before. Below that you can see our generic abstract class called baseAction, which, since it implements action, it has to set type to something, so we simply set it to null because we won't be using it at this moment. We're going to define it later. And then we say that this baseAction has one generic type t, and then we say that our constructor has one simple payload public argument type of t. So below that you can see that load product now implements, instead of action, implements baseAction, and it, instead of this t, sends string. This would mean that whenever we call this, instead of the constructor public payload t, it would, under the hood, create constructor with public payload string. Now, this original idea didn't came from me. It came from my colleague Christian, sitting in the first row. You might know him from the meetup.
Best slide ever.
And since we are building a lot of enterprise applications, we have a lot of code duplications, and boilerplate is something we battle with every day. So we thought, okay, if we did this for actions, what else can we solve? And we decided to take next thing directly into the hornet's nest, the effects. This is how typically effects look like in NGRX. So you have the create effect, which listens to the pipeline of actions. You filter out some specific action. In this case, we filter out load product action. As you can see, we are passing this constant type that we have defined. Then we are simply using map to pluck out the payload from the action. And then we use the switch map to call our service to get products, which is asynchronous call. It will make a call to the backend. It will fetch products for us based on a product ID. It will return the response. And then if the call was successful, we're going to map this response to the product loaded. Otherwise, if it fails, we're going to map it to product load failed. And pretty much all the effects that make some backend call look like this. Also, this effect has two parameters. One is the actions, the whole pipeline, and the other one is usually the service that you want to use. So usually per module you have a single service that handles all the API calls, and this is how you write it. Now, these are the only things that are different between actions. What type of action we're listening to, what is the actual action that we want to take, what is the method from our service that we want to take, if it's successful, which action should I take, if it fails, which failure action should I fire, and at the end the whole effects class points to one service. Now, this is how we solved it, right? If you come back here, you saw that these are the only things that are different. So what if we could write it like this? Just put the stuff that's different and have everything else automatically generic for us. So we came up with these constructs of helper effects, or effect helpers rather, where we can now say we have a switch map effect. So what it does, it will take the load product type, it will switch map it, it would take the payload, it would switch map to get product method. If it's successful, it would call it product loaded. If it fails, it will call product load failed. And as you can see that it extends the base effect. Base effect takes one generic parameter, which is our service, and we pass this service in the constructor. Now this is how this whole looks under the hood. So you can see the base effect, it has one generic parameter s, and the same parameter or same type is then used within the constructor for the service. You can then see the switch map effect that takes one parameter t, it extends our base action that we defined earlier, and it has action type, which is string, it has method, which is key of s. Now this is quite important. If you looked at this slide, you probably realize, okay, there's a string, so you could just easily make a typo. Well, you cannot, because by using key of s, you're actually telling your transpiler that whatever is passed as a method has to actually be method on my service. Otherwise, the transpiler will complain that this is not correct code. And then you have two actions, success action and fail action. And then the body of this method is actually just copied body from our original effect. And this is how we solved some other issues as well. So when you want to make some code to the backend that is post or put, so something that changes and that should be treated sequentially, switch map probably wouldn't be the best case, so you can use concat map. And for this, we have also concat map effect. But this isn't the only thing. For example, whenever things fail, we would like to inform the user about it. And this is how we do it. So we usually listen to the failed action. Again, we take out the payload, and then we fire at failure message. And the way our applications usually operate is that we have one component that listens to this at failure messages and then shows these toaster messages every time error happens. The same thing we have also for successful messages. So with these effects, we simply fire the messages whenever needed. And again, the only thing that's here different is which type of action we're listening to and what is the actual message we want to show. So we could simply write it like this. Yeah, amazing, right? So with this thing, you can create generic methods that will serve your specific application. This is how we use it in our application. It doesn't have to map your architecture. You could be using effects in a different way. But by using generics, I'm pretty sure you have a lot of duplication between your effects, so you can just figure out what's common between your effects and create a generic wrapper around it. Now, the next thing to solve was the reducer. So this is how a typical reducer looked like. You have some switch case. As I mentioned, it has two parameters, current state, action, and produces new state. Usually had some switch case, and then based on a type, it will return different states. Now, one thing we realized quite early is that there's also some sort of algorithm behind all of this. So you could say that all our actions fell into 3 different groups. First one was loading action. That's when you fire an action to load certain data. And when you fire an action to load certain data, you usually want to set the flag loading to true. This will probably show some spinner on a page. And you want to reset all the previous errors. Now, if action fails, you want to stop the loading spinner, and you want to feed this error message to your error message field. And then if the data came back, if data was loaded, you again set the loading to false, loading has been finished, and then you do some meaningful change. So you store your data into the state. So as you can see, those are kind of 3 types of effects, 3 types of actions. So instead of having 1 base action, we actually came up with 3 base actions. One is base load action, the second one was base loaded action, and the third one was base failed action. Now, all these base actions had a hidden baked-in field that told us which type they belong to. So this helped us then later on to handle different cases. For example, whenever we used reducer, we realized that pretty much all our load reducers work the same. We just set the field to loading, and that's it. There's not much going on there. The same was with failure. So we set loading to false, we set error message, nothing else, nothing specific. So instead, we could replace our huge reducers with a lot of switch cases with our simple base reducer, which handles all the load actions the same way, handles all the failure actions the same way, and then the only thing we want to handle, if we want to handle differently, is handle loaded. So this is where the meaningful changes are happening. And then you can write it simply like this. And if you look at the signature of the handle loaded, it takes state, action, and it returns state. So if you're one of those that switch to the new NGRX and use create reducer, you can use the same create reducer instead of handle loaded. So you can even more simplify this code. But as I said, we were working on this solution in parallel, so this talk doesn't include a create reducer, but I will mention it later. Now, there's one slide, or actually 3 slide issues with action type that we define for each action. Now, as I mentioned, that using string might produce some syntax errors, so you have to use these consts or some enums to represent it. And this inevitably leads to these long sausages of variable names, which one presents the feature or module where this action belongs to, and then second is the actual class name. Now, once you have some effects or some code that has a bunch of these actions, your code looks bloated for no reason. The second thing is that your action type is nothing but a string. You can use a good action hygiene to make sure or hope that it's really unique, but no one can guarantee that this string is really unique. It's just a string. You can prepend it with a module where it belongs. You can have like really specific name to make sure that it's unique. But as I said, it's just a string. No one guarantees this is unique. And while this is cool while debugging, because whenever something happens, you can see what actions were fired and you can follow the whole flow. In production, you don't have this switched on, so you don't have debugging switched on. And then you have a bunch of waste in production because you have all these long string names that are used just to figure out what is the difference between actions, but they don't really bring any benefit. One thing that actions had was constructor. So if we look at the constructor, it's shorter than this first line, right? Because it's just load product. That's the name of the class that we use. It's a unique because each class keeps a specific place in the memory. So there's no chance that you will have 2 classes pointing to the same memory, right? And it doesn't produce waste in the production because the names get compiled to a single character most likely. So it's taking a really small amount of space. And this is what we did. We decided to go typeless, to drop the type completely from the action, and instead use the constructor. So now, instead of those 3 lines where you had to define also type, we would have just base action that specifies the payload. We don't care about type, right? Because we now handle the classes directly. This also helps us then to write reducers a bit differently. So instead of comparing action type to some string, we simply take constructor from the action and compare it with a class. And finally, in effect, instead of using of type, we were using of action. Now, some of you might look at this of action and think, hey, wait, this doesn't really exist, does it? Well, it exists now. So meet of action. This is the operator which we built for RxJS. It's specifically built for NGRX. And it's nothing other than a simple wrapper around filter. So we simply say which actions we want to allow, and then for each action coming through the pipeline, we check, does this action matches constructors to one of the actions defined? Yes or no? And this is exactly the same way how the of type has been built. But instead of constructor, they are comparing type to the string. Now, in case you wondered, it's also faster than string, which only makes sense, right? Because you're simply comparing by reference, you're not comparing each character of the string. So based on some of the benchmarks, it's 15% faster, not much, because already this type has been quite optimized. And if you want to run the benchmark yourself, if you don't believe me, you can follow this link. There you can see the benchmark. Now, the bad thing is that it's not compatible with create action. The reason why it's not compatible is because when they introduced create action in NGRX team, they dropped the class completely, and instead they use a function that generates a simple object. Now, this simple object doesn't have a sense of class which it belongs to. It's simply an object that has a read-only field called type, which is the string that we saw. So you can still use a lot of stuff from this talk, not necessarily the of action, but you can still use it to simplify your reducers and to simplify your effects, even if you are using create action, create reducer, create effect. Now, NGRX is not, or state management is not the only thing you can optimize in your code. This is, for example, how we are building pageable lists in our application. We realize that a lot of our code, a lot of our views represent a list of items that are pageable, right? And each of these lists then have to have some sort of information, which page are they on. We would also like to know whether there is next page. And we realize there's a lot of stuff being duplicated. So instead, we created this pageable structure. And it's generic. It takes simple type. And if you can see here, it takes just 2 parameters. One is items, which is, again, a list of generic types. And page, which is a number. By default, it's set to 0. And then we set in the structure array of these items, and we set our page. And we have this nice function or nice getter called hasMoreItems, which simply checks if our list has the same length of the page size. If it does, then probably there's a next page. If it doesn't, for sure there's no next page. Now, in reality, our implementation is a bit more complex than this. There's a bit more checks. But in a nutshell, this is what we do. So we simply use generics to hide a lot of common functionality behind. And then we can use the same thing to make generic components. So you saw in Michael's talk some generics with services and with components. So for example, we can now create a component that again uses this generic pageable list, and we have a simple observable of this pageable list. And one thing we realized that for most of the pages, we are taking the ID or some property from the activated route, and then we use this to fetch our first set of items. And we always have some selector that fetches the items for us. So we could simply hide this common functionality behind this pageable component, and then we would simply say that our class extends the pageable component, and we would specify the type, which is the main type of our items we want to show. Now, this hopefully wasn't too technical for you. Hopefully you were able to follow. Generics are a really powerful toolset, and if you haven't used it so far, if you don't know how it works exactly, I suggest you go to the TypeScript documentation and see how it works and start using it in your application. If you did already use it, I urge you next time when you copy-paste some code and when you come into a situation where something is just too boring because it's too repetitive, try to find common patterns and try to replace this functionality with generics. Generics gives you a different set of classes with which you can look to your code. And every time you apply some generics, you inevitably remove a bunch of code. And the best thing to do when you remove a bunch of code is to play your favorite goodbye list. So this is my goodbye playlist. You can find it under this Spotify link. So there's some classic songs like Bocelli's Time to Say Goodbye or Placebo's Song to Say Goodbye. For those of you who saw German series Dark, you can probably recognize the Aparat song Goodbye. And there's even one song from a Serbian band, Auf Wiedersehen, which means both the name of the song and the band means goodbye. So with that, thank you for listening. You can follow me using handle Miroslav. Again, here's the link to my Spotify playlist. Some of the code, early version of this has been developed under my GitHub account. Here you can find it under nghelper. It's a bit outdated. Our project moved on since then, but I promise you in the upcoming weeks it will come up to date, and it will also cover cases where you use create actions and create reducers. There's also, it's called nghelper, not ngrx helper, because there's a bunch of other things in this solution that you might find helpful for your project. And using generics might not make you superhero, but at least you will look like a local superhero in the eyes of your colleagues. Thank you.